Alrighty. Today we're going to start chapter 6. Chapter 6. I think chapter 6 is the easiest chapter of them all. Basically, we're dealing with probability as area under a curve. Okay, before we said that probability can be written as a fraction, a decimal, or a what? A percent. Okay, that's what we talked about earlier. Now, in chapter 6, we're going to write it as an area. Now, there's two types of distribution in chapter 6. One is not used a lot, but I need to show it to you, and that's uniform distribution. The other is normal distribution. So we'll go over uniform distribution first, and then we'll go over normal. Okay. Uniform distribution is basically having to do with something that stays constant. What is the only thing that you know of in the universe that's constant? What doesn't change? Starts with a T. Time. Time. Doesn't change. Why? What do you mean it doesn't change? Does it slow down or speed up? It doesn't either. It doesn't either. It never changes. It doesn't change for anybody. I don't care who you think you are. It doesn't change. All right? So, that would be a uniform distribution. How about the percentage of humanoids in this class? Well, that would be uniform because there's no cats and dogs and donkeys in here taking class. So, chances are, that's a uniform distribution. Now, when you throw in weights or heights or eye color or stuff like that, you're going to have variation. You're going to have blondes, brunettes, redheads. There's the variation. But if you do humans, is there variation? No, because everybody's human. So, and time is the same thing. Time does not stop. It doesn't speed up, and it doesn't go slower. It may feel like it goes slow, but it doesn't. It goes the same time. So it's constant. So a uniform distribution is going to look like a rectangle. Now, uniform distribution and normal distribution have something in common. They both have an area of what? 1.0000. Uniform, well, normal distribution and uniform distribution have the same area. Now, why is it 1.00? Because the highest you can get on the probability scale is what? 1.000 or 1. So, no matter if you're given a normal distribution or if you're given a uniform distribution, the area of the figure is equal to what? 1. Now, a lot of people say, well, Hubert, why do you write 1.000? Well, this is a Hubertism. I've been doing this since I've been teaching Math 120. I write that in terms of 4 decimal places. Now, why do you write it in 4 decimal places? Because I want you to write down and remember that 4 decimal places in chapter 6 means that you are dealing with what? An area. If you see anything in chapter 6 that has 4 decimal places, you're dealing with an area. Where's Miss Holly? She's sick, is she? Right. What if you have 2 decimal places? Well, if you have 2 decimal places in this chapter, you're dealing with a z-score. And I'm just going to go ahead and tell you that. I mean, that's the z-score we use for normal distribution. But I'm going to go ahead and tell you the 4 places and the 2 places now. I was playing with my cat the other night and I got scratched. I'm glad I gave them shots. They're foaming at the mouth. Where will you work? You work for Bobby? What were y'all doing? Throwing it around or what?
No, it has, okay, somebody said it got in that golf course and they don't do roads, so we didn't think anything about it, and then it started, it was fine when it first came in, then it started having more launch personalities.
Well, you got to remember that some people don't know what possum and raccoon looks like.
Yeah, we figured that out. It did like a lot of people we have to use.
Bobby's up here, right?
I didn't know that. Well, they so ugly, they look like they got to get rid of disease, so they probably.
Some of them are nice.
Yeah, they can be great.
Oh, he went his next.
They're so slow. I mean, okay. Yeah, people at home were talking about possums. All right. So this is a uniform distribution. Now let's go back to your 5th grade math, Mr. Debo. What is the area of a rectangle? Remember? Length times the width. Darn, he took the board away from Mr. Hartman. That was the one thing he knew today. All right, base times height. I like to use base times height because if I use length times width, some people can't figure out what the width is because this is height. So we'll use base times height. The area of a quadrilateral is equal to base times the height. Now somebody tell me what we already have. The area. So area is going to be what? Okay, now Mr. Harbin could not mess this up. Okay? There is no other area in chapter 6. Okay? So if you put another number here for 1, don't tell anybody because I've just told you that you can't mess it up. 1 is going to go where the area goes. Well, what else do we have? Well, in this problem, we don't have anything, but I'm going to give you an example. A professor, I don't know how to spell professor. 2 S's, 2 S's.
One F.
Just 1 F. I don't know. I don't go around spelling professor. Damn old teacher. Here we go. I don't like to be called professor anyway. Teacher usually teaches 50 to 60 minutes what is the probability of the teacher going to 58 minutes? Or letting you out after 58 minutes. What's the probability? Or, no, we'll say the probability of up to 58 minutes. What is the probability that that teacher is going to teach up to 58 minutes? Well, we've already been given the base, 50 to 60. That's that right there. So, here's your base. So if you got a base, what do you think you got to find? You got to find the height. So 1 is equal to, what's the base? 10 h, and divide by 10. Now you might need a calculator for this. 1 divided by 10 is 0.1. So your height is equal to 0.1. And I'm going to take my handy dandy red highlighter, or, purple. And I want to highlight this right here, because this is what you're going to have to find with uniform distribution. Okay? So you need to make a note. The height is what you need to find. When did it rain? Early this morning, not before we got here. Yeah. Well, I don't remember it raining, but I've been teaching on that.
I mean, it was raining a little bit, around a little bit after 8.
Yeah, I was teaching. Oh, what did you say? The height? The height is what you're going to find. All right, now, I have found the height, and I have the base, it's 10, and I have the area right here. But I want to find the probability that the teacher is going to teach up to 58 minutes. So what's my base? 8. And what's my height? And what's 10% of 8? 0.8, which is 80%. And that's how you do uniform distribution. And I'll give you a problem here in just a second. And that way you'll have two. You'll have an example, and then you'll have a homework problem. You're only talking about 2 problems on the test. The rest of them are going to be normal distribution out of 6.1, 2, 6.3. What does the syllabus say we go to? Because I only do 3 sections out of chapter 6. 6.5, that's it. And that should be more than 1 or up to, what is it? What is the title of chapter 6? Oh, you don't have it. I mean, 6.6. 6.5. Yeah. That's where you just divide. Instead, no, I'll show you just a minute. But that's, everybody got it written down? All right, so let's do a uniform distribution out of the homework. So that way you'll have one to do by yourself. I don't know what I'm doing. Oh, okay. I'm going to study. I'm going to ebook. Oh. You just have one of those days you just can't get with it. It's every day? Okay. I got to start. I don't know if they even had any on the homework for uniform distribution. They should. Well, I was going to try to find one that was already made, but they could give it to you in paragraph form, so most of y'all will probably skip it. No, I'm just kidding. Well, let's do number 2. It says the waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed, hint, hint, between 0 and 6 minutes. Find the probability that a randomly selected passenger has a waiting time less than 7.75 minutes. So 45 seconds or something like that. 0.75 minutes. Isn't 0.75 minutes? Isn't that 45 seconds? 0.75 times 60. Should be. Alright, so draw you a rectangle. And the base is what? 6 minutes. 0, 1, 2, 3, 4, 5, 6. And you know this is 1.0000. So 1 is equal to 6 times the height divided by 6. 1/6 is equal to h, or 0.167 is equal to h. And they want to know, so I'm going to take my handy dandy eraser and erase that now. And they want to know, find the probability that a randomly selected passenger has a waiting time less than 0.75 minutes. Well, this is 1 minute, right? So 0.75 would be where? Right in here. Yes, no, maybe. So they want to know 45 seconds. What's that area? So what is the base? 0.75. The base is 0.75 and the height is 0.167. Now you need your calculator. Unless you're Rain Man, you're not going to be able to know what that is. So 0.167 times 0.75. Ms. Campbell, what'd you get? .125. So if you go to the subway today, based on this you've got a 12% chance of waiting in less than 45 seconds. Now, a lot of people say, well, who cares? All right. There are some people that have jobs that worry about stuff like this, and they work for the subway system, like in New York, the big city, the real big city, not like Rangers, but the real big city. They worry about stuff like this because 45 seconds in the city, you can walk, you can get something done in 45 seconds, or you can get something done in 2 or 3 minutes in the city. They very fast paced, so it makes a difference if you're waiting 45 seconds to some people. Something else that this, talking about time, well, anything having to do with time is pretty much going to be a uniform distribution. I was trying to think wait time in a bank line, the teller line, waiting to deposit checks or make transactions. That is a big thing with banks, and they will hire somebody to come in and watch their lobbies and time and see what the best way, if it should be something like that, and then you go to the teller you need to go to, or it should be just basically like that, and then you have the little thing right there to go which teller you need to go to. There's actually businesses that go out to banks and figure out which, and some of you are like, what is that? Well, how you stand in line. You remember going to Ryan's a long time ago, and you used to have to stand in we called them cattle guards. You used to have a bunch of cows. You used to have to go like at Six Flags. You have to go around and around. Well, some people don't do that. Some people would much rather, not the other one. What's the other one? Dick's. You go in the Dick's. You don't go through this right here. What do? You just, and Ulta. I go there. Yes, I go there. Ulta. Yeah. When you go there, you go right to a spot, and you what? You wait. At Old Navy, you go right here and you wait. You don't go through this. And so, some businesses want to do that. Some businesses, and that's uniform distribution to minimize wait time. Airports or airlines, they use uniform distribution for wait times. Okay, so that's uniform distribution. I think y'all shouldn't have any trouble with that. Normal distribution is like so, and of course, if you've had me, you've been doing this ever since the first unit, and that's why I do it. In Chapter 6, in 6.2, mu is going to be 0, or x bar is going to be 0. It doesn't matter. They're both the means. And your standard deviations are going to be z-scores. So 2 to the right, and 2 to the left. And what percent falls between 2 standard deviations? Or 2 and negative 2 z-scores. What percent? 95%. And it's also called what? Starts with N. Between 2 standard deviations, what's it called? Normal. Appreciate you being interactive. All right, so we got normal from -2 to +2, and we've got 95%. I want to talk about a couple of things about this normal distribution just to knock the cobwebs loose. Remember me telling you how to read this like a gas tank? You remember me talking about that? Okay, well, we're fixing to do that. This is about 25%. This is what? 50%, 75, 95, and so on. I want you to take the highlighter, and I want what you're laughing about. And highlight that middle section right there. That is the 50th percentile mark. In other words, the left-hand side is over here. Now what z-scores correspond to the left-hand side? The left-hand side of the mean is signified by what z-scores? Negative z-scores. Now a lot of you are saying, golly, Hubert, that's easy. Everybody knows that. Yeah. Okay, and the right-hand side is signified by positive z-scores. Now, the reason I'm telling you this is when we get into the table in just a minute, and we get into the questions, it depends on where your point is. Wherever they put a point, whether it's on the left or on the right of the mean, that tells you what to do. Okay? Now, of course, just to remind you, z-score is equal to x minus x bar over what? Standard deviation. Or z for the population is equal to x minus mu over c. And this is here the same thing. It doesn't matter, it's the same formula. Okay? Now the area under this curve is equal to 1. And the z-scores are down here. Now I'm going to make sure everybody's got that, and we're going to the next drawing, and then we're going to talk about what we're actually finding. Now, the two type problems you're going to have in 6.2 are given a z-score, find the area, and of course I put area in quotation marks, but what is area? Probability. The other type problem, given an area or a probability, find the what? Z-score, Hubert. That's right, class. There's the two type problems you're going to have in 6.2. Now, there's 2 or 3 ways that you can find the area. One is the table, 2 is the calculator. We're not going to do the calculator until we learn how to do the table. So that way you have 2 ways to find it in case something happens to your calculator or in case you forget your table. You can use the calculator, vice versa. So, but you can't use the, I don't think you can, I don't know. I know you can use the calculator to find the area, but I don't think you can find the z-score with the calculator, but I'll have to research that because I can't remember. I've never done it. So, and this is so easy that some people think it's easier just to look on the table than it is to punch everything in the calculator. And in some cases it is. All right. So there's your 2 types of questions right there for 6.2. So you just basically have to read the question. Now, how do you find the area of the z-score? Well, if you have your book, look in your book for the table. It's a cardboard table. If you don't have your book, then all you have to do is go to Google, and I'll tell you what to type in. You type in Triola. That's the name of your book, the author. 12th edition. If you know how to spell edition. Table A2. And it's the first one. Right there. Click on it and print it out. About 5 or 6 pages. Or 8. Or you can get it out of your book. Where was it in your book? Okay, so it's in the middle. I mean, somewhere in there. Okay. It's in your book. Usually with the hard copy book, there's 2. One in the middle and one in the, hold on a minute, and one in the back. But with the a la carte, you just have one, evidently. Hold on a second. Okay. I was looking to see if they got my attendance. Okay. Go to A2. And there's the 4th page. Go to 5th page. 5th and 6th page. Page 5 and 6. If you just want to print out 5 and 6, that's fine also. Now I want everybody to look at the first sheet right here. It says there's 2 or 3 things I want you to highlight. The first thing I want you to highlight is I want you to highlight that right there. That right there, you can't see it with this picture, but it's that area right there. And if you look in your book, you can see the area better. It's blue. In other words, when you read this table, for the negative values, that means, let me take a handy dandy highlighter. No.
Priority 1 message coming in on secured channel.
Okay. Anything over here as far as a z-score or a area. If you're given an area, you got to go to this negative z-score table because why? It's on the left-hand side of what? Of the median. Anything on the left-hand side of the median, you look on that one. Okay. Now, Hubert, what do you mean by cumulative from the left? Cumulative from the left means that these areas, right here, all these areas, all the way down to 0, are coming this way, like that, until you get to here. What do you think the highest area is going to be at this point? 0.5000. That's right, class, because it's what? Halfway. What would this one be right about there? Right here would be what? 0.025, right? Or 0.25. And then back here would be 0.025. So that's where all these are. And of course, these are your corresponding z-scores. Oops. You know, I know how to make $1 million. I can be a millionaire. If I could figure out a way to put a cap on my head and tell this thing what to do. That way I wouldn't have to keep punching all this stuff over here. I just write it. If I could develop that, I wouldn't have to work the rest of my life. But anyway, this is point, now that's negative what? 1, and that's negative 2. So if I wanted to find the area right here at negative 2, and I look at negative 2, which is pretty good. At 3, negative 3, I look at negative 3.0. So what kind of probability do I have right here? 0%. That's right, class. 0, 0, 0%. Are y'all following me? Or what? Huh? What did you say? What'd you say? I don't know anything. Okay, whatever. All right. Now, what if you're on the right side? Well, let's take a minute and again, I want you to highlight cumulative area from the left, and that is right there. Now, why is this positive z-score? Because it is to the what? These values and these areas over here are going to be to the right of the mean, so you will read the positive z-score. So let's say that this z-score is 1 right here. Then you find 1.0. And 1.0, what's the area? What's the green area at 1? 84%, or 0.8413. And after we do the first 2 or 3 problems, those of you who've never seen it before, you'll catch on to it. There's only one other thing I need to tell you, and that is the left-hand side is no problem to get. Left-hand side area is no problem because the card reads from which side? The left-hand side. But what if the question asks, what is the area greater than? What side is greater than? The right-hand side is greater than. Then what is the left-hand side? The left-hand side is less than. So if you see less than in your problem, then you know you've got to read the left-hand side. If you see greater than, then you got to find the area where? You got to find this area. Well, Hubert, this don't do the right-hand side. So you have to calculate it. Now, if the area under the curve is 1, and we can get the left-hand side, then what do you think the right-hand side is equal to? Which is called the complement. Who said that? Y'all did good. Miss Harkness, was that you? It's your mom. That's what it is. She gives you the smart thing. Okay, so right-hand side is equal to 1 minus the what? Left-hand side. And in a minute, because right now there's 2 people in here. One, oh yeah, I remember this from high school. Okay? And then the other one, I have no idea what he's doing. So the ones that saying, I have no idea what he's doing, you'll be all right. I promise you, this is the easiest section in the book. Okay? So let's go ahead and do a problem. Let's go here. Is that the homework? Yeah. Alright. The first thing you want to do when you when you do one of these problems, if you don't have a picture here, you need to draw one. Now, I used to tell students to do this, and most of them would do it, but then students started getting what? Lazier and lazier. Students coming out of high school, lazier and lazier. So I started telling them, get you a sheet of notebook paper, and here's your sheet of notebook paper, divided into 8 boxes, and draw 8 of these guys, like that, with 2 standard deviations on each side, and run you about 20 copies. And that way, you won't have to draw this dadgum curve every 5 seconds. Okay? So for the one person in here that's going to do that, I think you're going to like doing it. The rest of you are going to whine and complain. Right? Nobody's going to say anything. All right. We all know Mr. Harbin is going to go home and do that tonight. Right, Mr. Harbin? So draw a picture. I really don't like this picture, so I'm going to draw in 0.64. Where's 0.64? It's between 0 and what? 1. Good job. I can't get him coming past you. -1, -2, and 0.5 is right here. So 0.6 be right in here. Now, of course, you don't have to be immaculate. It doesn't have to be very detailed. And they want to find the area to the what? To the left of it. And that's assumed to just keep on going. Now, if you remember, I said there's 2 types of questions. One, they're going to give you a z-score and you find what? And they're going to give you an area and you find what? So which one is this one? Find the area, because you're given a what? 2 places. You're given a z-score. 2 decimal places is given. So what do? Well, you just quit. You hit your handy-dandy table here. Which table do we need? Do we need the negative or do we need the positive? Positive. Thank you, class. I don't see a negative up there. All right, so what are we looking for? Z-score of 0.6 what? 0.64. So I'm going to find 0.64. Let's see, it's 2 decimal places, so I'm going to look at the 4 decimal places, right? No. You're going to look at 0.6, and then 0, 1, 2, 3, 4. 0.7389. And I'm going to highlight that for you. I done forgot it. 0.6 and point what? And there is your answer, 0.7389. Now, of course, y'all can't see it up there, but I'm not going to blow it up. You just need to trust me and bring the table to class. That's point, so this is point, I done forgot it, 7389. Thank you. So 74% falls at a z-score of 0.64. Now you're going to see the application to this in 6.3 and 6.5. Right now, this is just how you actually work it. Okay, you see how that works? Any questions? All right, let's do a nerd.
So that's the answer you typed in?
Yeah, you type in 0.7389. Because if you look at the question, which I can't get rid of this,
At the top.
I can't, oh, there it is. Right there, how many places? 4 means area. And you type that in, 0.7389, and you feel good about yourself. .7389. All right, let's do one that's a little bit different. All right, try that one. What are you given? So that means you're going to find? What area do you want? Right hand side. You got to find the left hand side first. Or you could just quit.
What do you mean by right hand side?
The table will only read from the left. Zero
so
to
it's the part that
the shaded part is what you're trying to find.
Okay, gotcha.
That's why it's blue. Now we're going to cover some more of this 6.2 Monday, or whatever day y'all come back, Tuesday or whatever. All right? Do not go home and do the homework and think you're going to be able to do all the problems, okay? If you want to hold off until Tuesday to do the homework, that's fine for 6.2. I've got to cover another couple of the types, and they're probably, out of the 3 types of problems, they're probably the most difficult. They're not really difficult, but you've never seen it before, and that's why it's difficult for some of you. So if you want to take the weekend off and not do homework, that's fine, and just start Tuesday on 6.2. It's up to you, or you can go through 6.2 and just do the ones that are giving you one Z-score or one area. If you see one with 2 Z-scores, you might want to skip it till Tuesday. Okay? All right, so here we go. Negative 1.12. Well, here's negative 1. So negative 1.12 would be where? Right about there. All right. Now, the only thing I know is that the table will only give me this area right here. Okay? That's the only thing the table will give you. The left-hand side of your mark. Because we all read which way? Left to right. So it reads from the left, 0, or negative infinity, and it reads to the right. So we got to find this area first. So we go to our handy dandy table, and do we get positive or negative? Negative, and we need to find $1.12. So $1.12 is going to be 1.0, and then we're going to add the 10 cents, and then we're going to add what? 2 cents. So $1.10, 0, 1, 2. 13, 14. That is. All right, so this is .1314. Now, we want the what? We want the right-hand side. Because it's asking for that. Well, the area under the whole thing is what? 1. So the right-hand side is equal to 1 minus the left-hand side. So that's going to be equal to 1 minus .1314, and that's going to be .8686. So what's the percent in yellow? 87%. Of course, they don't want 87%. I'm just trying to show you what that means. It's 0.86, whatever, 86. Now, you are able to do given one area or one z-score. So if you want to work on those, that's fine. Do not work on 2 z-scores. If you get 2 z-scores in a homework problem, just stop and we'll do those Tuesday. I'm going to make everybody here today. It's already halfway through the semester, so if you're still with me, I'm not going to worry about it.